This lesson gets into some more of the abstract elements of what we've been talking about with the division and what it really means with a graph and all those types of things. So here, let's find it. F of x equals 2x cubed minus 5x plus 2. We're going to divide f of x by x minus 4. What in the world are you talking about? We actually just learned this lesson. So 2x cubed minus, actually let's make it plus 0x squared for obvious reasons. We're missing an x squared. Minus 5x plus 2. And we're going to divide it by x minus 4. Okay, so same thing we just did. So let's do this pretty quickly. So 4. 4 is going to go, like, so we have 2, 0, negative 5, 2. This process starts to go really fast once you get the hang of it. So let's go quickly. 2 comes down, multiply, put it there, add, multiply, put it there, add. Usually when they get big like that, you know you're going to have a remainder. We put 27. Wow, long day. 4 times 27 is 108. 108 goes here. We have 110. I hope I didn't mess up anywhere. Let me check through it really quickly. 32, 27. Yep, we're good. Okay, so we just divided that. Well, let's get the actual answer. When we divide it, we have 2x cubed plus 8x plus 27, and then we have a remainder of 110 over x minus 4. Okay, so there we go. We did it. We did what they told us to do. Now, we're going to notice something kind of cool about this in a second. I want to find f of 4, meaning I want to take that 4 and I'm going to plug it in here. It is not a coincidence that I picked 4 for this problem, and I had x minus 4 for this problem. So let me talk about that very quickly. If I had x minus 4 equals 0, what would x be? Well, 4. This is not going to be a coincidence that this is a 4 and that's an x minus 4, okay? So I want to plug in 4 into that function right there, and I'm going to write it by hand, but then I'll grab a calculator. So 2x cubed, oops. Instead of x, I'm going to put a 4. Glad I have my whiteout handy again. So 2 times 4 cubed minus 5 times 4 plus 2. I don't need a calculator for this. 4 cubed is 64. 64 times 2 is 128 minus 20 plus 2. What do you get? 110. Does that number look familiar? It does. Okay, so I can use synthetic division to evaluate a function, to evaluate a polynomial function. So polynomial meaning it looks like this. It has several terms and, well, it looks like this. So we'll get into non-polynomial functions later. But I can evaluate a function by using synthetic division. So if I said, hey, what is f of 4? I could just put a 4 right here, crank this out and get 110. Or I could plug it in here. And sometimes it's more practical to do this. Sometimes it's more practical to do this. But the bigger idea is that it works. So the remainder theorem is something that we had to prove to be true, but someone proved it years ago. Remainder theorem states that for any polynomial, whatever it is, we call it f, dividing by that binomial, x minus a, let's pause right here. Well, if I have x minus a, what would I use for division? Positive a, right? Will yield a remainder that's equal to, well, whatever I got when I plugged a in. So we're just going to take that idea and run with it. And this is really going to be polynomial division all over again with synthetic. I mean, that's it. That's what we're doing. So find f of negative 2 for this. You can do it by plugging in a negative 2 here, here, and here. Or you could just divide it by x plus 2. Really quickly, this just reinforces the idea that I can plug it in or I can use synthetic division. Meaning, let's do a negative 2 and 1, 4, negative 3, 1. Here we go. Oh, I hope this one works out the way I want it to. I have a very strong feeling it is not. All right, 1, negative 2, 2, negative 4, negative 7, 14, 15. Ha, 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 ha. Okay, what does that tell me? Well, if you're doing the division itself, it tells you you're not quite done. So if you want to say, well, 1x squared plus 2x minus 7, yeah, fine, cool. That's not what they asked, though, actually. They said find f of negative 2. We found it. That's it. So final answer over here in red, if I plugged in a negative 2, here, cranked it out, I'd get 15. I could do this, I could do it by hand. Either way, it works. Using the same function from the previous problem, evaluate f of 5 using synthetic division. Okay, well, let's do that. Again, just reinforcing the idea. So 5. Okay, now, whoa, all right, let's think about this. Should I put a 5 here or should I put a negative 5 here? If I give you a binomial factor, like, oh look, I have x minus a, or I have x plus 2, then I need to change the sign. If I say blah, 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 I give you a number, plug in the number, use the number. Okay, and we change between the two, and I don't want you to get confused because sometimes I could evaluate it at a, or I could talk about dividing by x minus a when the opposite of that is a. Okay, I think you got it. Sorry if I'm confusing, but use a 5 because this didn't, well, never mind, use a 5. Same function from the last problem. So 1, 4, you're probably already done with this while I was rambling. So here we go, switching colors again. I don't know why. 1, 5, 9, 45, we're going to have a remainder. 42, oh boy, 210, 211. There we go. All right, cool, it works. Which means that I need to check through my work and make sure I'm right. 210, yeah. So f of 5 equals 211. There we go, we found it. So now we're going to find f of 5 for this function, and this is really going to drive the point home a little bit more, okay? So find f of 5, so 5, and then I know you're like, oh my goodness, I got it. Synthetic division. Super easy, you're beating a dead horse. I hear you, I got it, but this one's going to prove another point. 5 times 1, 0. Okay, lucky yes. 5 times 0, 0. Negative 6. 5 times negative 6, negative 30, 0. Okay, cool. All right, I'm about to show you something really cool on a graph. It's going to knock your socks off. F of 5 equals 0. I wonder what that means. Well, I'm going to graph it and show you something. Then we'll talk about what's in this little box down here. Then we'll go to another video, flip it over to the back. So here goes, y equals, I'm going to type that in, so x to the third, trying for there not to be a glare. Oh, there's not, good. Minus 5x squared minus 6x plus 30. And if I was to graph this, I'm going to just go with a standard window. It does this, it does that, it does this. Okay, I want you to notice what happened, and it's really, really subtle. When I plug in an x value of 5, what do I get? Well, let's ignore the calculator. I get 0. Let's look at the graph and see what that means. If I go over here to 5, 1, 2, 3, 4, 5, then that is where I cross the x-axis. That is an x-intercept. Okay? We could also call this a 0 or a solution. So a factor theorem states that if a is a 0, I'm going to give you a really quick definition. This is an x-intercept. We call it a 0 because y equals 0 at an x-intercept of a polynomial. The factor theorem states that if a is 0 of polynomial f of x, well, take out the word for, whoops, typo, then x minus a is a factor and vice versa. So let me tell you what that means. If I was to divide x squared minus 5x, x cubed minus 5x squared minus 6x plus 30 by x minus 5, it would divide with no remainder. We got that. The factor theorem states that if a is a 0 of a polynomial, then it's a factor, and vice versa. So if this is a factor, then a is an x-intercept. Okay, so I'm going to start a new video just to kind of break this up, and we're going to reinforce this idea on the backside.